The motors we're going to be using are the 37D millimeter metal gear motors provided by Pololu.com. And the schematics that we're given for these motors are in millimeters. So we're going to go ahead and open a new part file, and we're going to change our units to millimeters. And to do that, we go to the options button here, and under document properties, we can select units, and we can choose the millimeter gram second unit system. Okay. And we'll go ahead and begin by sketching on the front plane. Now what I like doing is loading up the front sketch with as much information as we can. So we'll go ahead and begin by sketching a circle centered on the origin. And we'll drag that out there. And we can also draw the bolt circle here for the mounting holes. So we can draw another circle, and we'll make that inner circle for construction. And we'll also include the geometry for the output shaft down here. So we're going to draw a center line from the center to the right, and we can dimension that to be, what is that, 7 millimeters? Then we can draw two more circles, one for the output shaft housing and another smaller one for the output shaft itself. Okay, now that we have all our geometry here, we can start dimensioning. So we'll dimension from the inside out. So we can dimension the output shaft. It's about 6 millimeters in diameter, so we can right click and go to Smart Dimension, click on the output shaft circle, and make that 6 millimeters. And the output shaft housing is, where is that? It's right under my mouse. That's 12 millimeters. And then for the bolt hole circle here, we can assume symmetry in this drawing down here, and we can see that from this bolt hole to the opposite one is 31 millimeters in diameter. So we can dimension this construction circle at 31 millimeters, and the overall outer dimensions can be seen here in this figure as 36.8 millimeters. 36.8. Alright, so let's go ahead and zoom in, and we'll clean up our dimensions a little bit. Okay, and I still have one blue circle here because I didn't snap to the end of that 7 millimeter line. So once we do that, our sketch is fully defined. Another thing I want to add to this sketch is the cutout here on the shaft that makes it a D shaft. So we'll go ahead and draw a vertical line, and we'll dimension it. So we'll select the line, select the circle, and bring out the dimension, and we'll just hit the green check mark here, and then the dimension we have for it is 5.4 millimeters from the flat to the outer edge of the circle. So under liters, we can select the arc condition, and we'll choose max. That brings it out here. Then we can change the dimension to 5.4. And let's see, okay, that's all we need. The next thing we're going to work on is the location of the bolt holes. So we're going to define those by using points here, and once we finish the extrusions, we'll go ahead and use the hole wizard to create the holes. So we're going to put points on our construction circle here to represent the bolt holes. So we're going to put the first one here at the bottom, on the bottom quadrant snap here, and the next one is 15.5 millimeters, so we'll put that one somewhere around here. And because of symmetry, alright, that's really all we need. So we can smart dimension these 2 points here. So we'll click on the points and drag an align dimension. And as I right click, you can see the icon change from a locked padlock to an unlocked. So when it's unlocked, it stays locked in the align dimension, and when it's locked, you can change from a horizontal to an aligned to a vertical. So right now we want an aligned dimension. So we'll drag that down here and we'll put that at 15.5 millimeters. And that's it. So now we can mirror entities. So we're going to mirror this point, and we're going to mirror about this horizontal line. Green check mark. Alright, that's our other bolt hole. Okay, I should have also mirrored this bottom point here, but we'll go ahead and use our point command and put the other point at the top quadrant here. And now we can mirror these 2 points over to the right half. In order to mirror, we need a line to mirror about, so we're just going to draw a vertical line from the origin. We'll just click out in space somewhere. It doesn't matter how long it is. So we're going to mirror entities, and we're going to select the 2 points, and we're going to mirror about the vertical line we just drew. Green check mark, and we have our points there. Now, just for fun, we can verify the dimensions. So we can click on this one, and we'll have an aligned dimension, and it's 31 millimeters. So we're matching up with our schematic here. Alright, another feature we can add to this sketch is a circle that represents the actual motor section of the gear motor, which is this back half, the right half. This front half is the gearbox. So we can go ahead and draw another circle from the origin and drag it out here, and we'll dimension that. So right click, smart dimension, and actually measuring the motor, that is at about 34 millimeters. So we'll write 34. And there we go. So now we can exit sketch, and we're ready to start extruding. So we can go features, extruded base, and the contours. So right now we're going to extrude the actual gearbox section. So we're going to extrude everything. And we're going to extrude away from us, so into the negative Z direction. And that extrusion, that dimension isn't given, but measuring the actual motor, that's about 20 millimeters. So green check mark. Okay. And now that we have the extrusion, it hides the sketch we just did. So we can always go to the feature tree here and expand the extrusion, and we can right click on the sketch and do the eyeglasses to show. And we'll leave that open because that sketch has all of our information to extrude and for the whole wizard and all that nonsense. So we're going to do another extrusion, and we're going to select our sketch here, and the direction we're going to go away again. And we're going to extrude the motor section. So under select contours, we're going to do everything inside of the 34 millimeter circle. And don't forget to select that section. And the length of the extrusion is the 30 millimeters plus the 20. So that gives us 50. Green check mark. Alright, so there we go. So we have the back half of our motor here, the gearbox and the actual motor. And now we'll extrude the shaft and the shaft housing here. So extrude. We're going to select our sketch again. And we're going to select everything inside of this 12 millimeter circle. Let's see, and that gets extruded 6.5 millimeters. 6.5. Green check mark. So now all we have left to extrude is the shaft, so we'll select our sketch again, and we'll click Extruded Base, and we'll select everything inside the shaft here. And we're going to do the full diameter of the shaft, and let's see, that dimension isn't really given, but it's 6.5 inches plus the difference between the 15.5 and 12. So since our little input here is also a calculator, we can do 6.5 plus 15.5 minus 12, and that gives us our extrusion, or 10 millimeters. Okay, now we're going to extrude the part of the shaft that has the flat on it, which makes it a D shaft. So we'll do another extrusion. We're going to select our sketch and do another extrusion, and we're just going to extrude the D shaft portion. And that extrusion is 15.5 plus 6.5. or 22 millimeters. Alright, so there we go. So whenever you want to see a specific face or plane, you can hit the space bar and click the certain whatever plane you want to see, whether it's the front, back, left, right, top, bottom, isometric. So I want the front plane normal to us, and we'll go ahead and use the hole wizard next. Okay, so we're going to select the front face here, and then click on the hole wizard, and we're going to do straight tap threaded holes. So we're going to select that, and we're going to use ANSI, and the size are going to be M3 tapped holes. So M3 tapped holes, so that's what we need to select. M3 by 0.05. So that's the threading. And the depth's 7.5 millimeters is fine. So now for positions, you generally have to click on the face you want the holes to be on, and then you can drag and position them. So let's go ahead and make that front face normal to us, and we can click on all our points here. Alright, and to exit the positioning command, you just hit escape, and if you have one too many points like I do, you can always select the point and hit delete. And green check mark. And we have our tapped holes here. Now that we're done with this sketch, we can go ahead and hide it. So you can right click and select hide the eyeglasses. Okay, another feature we can add is the chamfer on the output shaft of the motor, which is this angled section right here. So we can go ahead and go to our fillet tool. If you drag that down, we can select chamfer, and we just select this outer edge on the output shaft, and it doesn't specify a dimension, so let's go ahead and see what this looks like. 10 millimeters seems a little bit large, so maybe we'll change that to 5. Alright, 5 is even pretty large compared to this picture here. So you can always go back and edit a feature by right-clicking on the feature, and then you can select Edit Feature. So we can change that 5 to, let's try 1.5. Alright, that looks a little more like it. So now we have our chamfer are flat. The only thing that's left is the terminals here on the back. So let's see. So we can go ahead and draw the terminals. So you can click on the back face here and hit sketch. And we're just going to draw a couple of center rectangles. And just draw them out here in space. It doesn't really matter where. Then we're going to draw a center line between the center of the two rectangles. And that's pretty much it for the sketch. Now we just have to dimension and constrain everything. So let's go ahead and right click on our center line here, and we'll select the midpoint, and holding control we'll click on the origin, and we'll release control, and we'll make it coincident. So we're going to add that relation. We're also going to select the center line here and make it vertical. And now we can also dimension these lines here and add a couple of constraints. So we'll select the vertical lines here. You click on them, left click, and then holding control you can left click on the other line and add a relation. So we'll make these equal, and we'll do the same for the horizontal lines. So we'll click, control, click, make equal. So now when we smart dimension, we only have to smart dimension one of the rectangles here. The thickness, it isn't really given, so we can call that 2 millimeters. And we'll maybe call this horizontal one 4. Yeah. And this vertical line here, we can smart dimension that at 21.4. That one is actually given. 24.1. And there we go. We can exit sketch. And now we can extrude our terminals, and that distance is 5.6. Now the overall dimensions of the terminals aren't given. They aren't really critical to the design, so you can just make them look aesthetically pleasing, or just make the dimensions easy for yourself, either way. But here is our motor. Alright. Another thing we didn't add to our motor is a little pocket they cut out on the front face here. This little crescent moon shape. That's just to make it look cool. You guys can play around with it and maybe sketch a crescent moon on the front here and do an extruded cut if you'd like. It's not really necessary at this point. So here is our motor.